Hi guys, this is our last section of notes over waves. So let's quickly talk about what we covered last time. We talked about the difference between longitudinal waves, which are moving parallel to the wave motion, and transverse waves, which are moving perpendicular. Remember the way I remembered it, longitudinal waves appear to be longer, transverse waves appear to be taller. We talked about a couple different behaviors waves can make. One is refraction. This is when the waves are bending due to passing through a different type of medium. So remember, a medium is just a substance that they're traveling through. So if this was water, the waves would travel at a different speed once they hit the water, causing it to appear bent. I have reflection, where the waves are hitting a surface and they're bouncing back. And I also have diffraction. This is when the waves are bending around an obstacle. The example I used for this one was sound waves, right? If you're playing music in one room, you can hear it in the other because the sound waves are simply bending around obstacles to get past. We also talked about constructive interference and destructive interference. Remember the word constructive associated with something positive, and destructive associated with something negative. So constructive, they're perfectly aligned, crest with crest, trough with trough, and because of that, it creates a bigger, larger wave. It's constructive. Or destructive, they're opposite. The crest aligns with the trough, therefore they cancel out. This is destructive. So if you remember from our first part of our notes, we talked about two types of waves. Mechanical waves, which require a medium to travel through, and electromagnetic waves, which don't. So today's notes are going to focus on the spectrum. These are all my different types of waves that are considered electromagnetic, meaning they are not traveling through a medium. So notice I have a very important relationship here between wavelength and frequency or energy. If you are not comfortable with the difference between wavelength and frequency, you might want to go review some past topics, or else this section of the notes isn't going to make much sense to you. But just for a review, the larger the wavelength, the shorter the frequency. They're opposite. So over here, notice this is a high frequency, but the wavelength between the different waves is very small. So wavelength and frequency, you need to remember, are essentially opposite. So this is a spectrum, right? It's a range. We need to be familiar of what it means in this range. Now, good news is that you do not need to memorize this chart. I will give you this chart. You have to kind of be able to look at this chart and understand it. So we're going to start from one end of the spectrum, the lowest frequency, therefore highest wavelength. So down here, look at this wave right here. I have a low frequency, but notice my wavelength is pretty big. At this end of the spectrum are going to be my radio waves. Next, I have microwaves. So notice as I'm going down this, I'm increasing my frequency or increasing my energy, and I'm decreasing my wavelength here. So I have microwaves next. Next, I have infrared waves, which includes this section of my wavelength. So anything that falls in this category is going to be infrared. Followed by light, which is visible light. This is the only range of wavelength that we can actually see from our eyes. So notice this is a pretty large spectrum. I have very large waves, very small waves, and this little section here is my visible light, and this includes all of my colors, which we'll get to in a second. So after my visible light, I have ultraviolet. I will abbreviate this as UV, just so you're aware. X-rays come next, and then my gamma rays. Gamma rays have the highest frequency, therefore the lowest wavelength. So let's talk about my colors. So maybe you guys have heard of this acronym ROY-G-BIV. This acronym helps us remember the order of my colors. And again, it does have to go in this specific order. So let's talk about what each of these letters represent. My red, which is the R, this red is going to be my low frequency, therefore largest wavelength. So red light has the lower frequency, large wavelength. O is going to be my orange, yellow, green, blue, the I is indigo, and violet. My violet light is going to have the highest frequency out of my colors, therefore the smallest wavelength. Okay, so this is that same kind of picture, but backwards to read it from left to right. So I have Roy G. Biv. So like I said, you're not going to have to memorize this chart, but you do need to be able to look at it and answer questions. I'll probably give you two options and you will have to tell me, out of these two options, which one has the larger wavelength, which one has the shorter wavelength. Frequency, larger frequency, smaller frequency, large amount of energy, small amount of energy. Remember, wavelength and frequency are opposite of each other, where frequency and energy, they kind of mean the same thing. So gamma rays have high frequency, therefore high energy, where radio waves have low frequency, therefore low energy. So let's look at a few questions that we might see. So I could ask you questions such as which one has more energy. So if I'm looking between X-rays and infrared rays, you want to find them on the spectrum. X-rays are right here, infrared rays are right here. Look at this wave diagram because it should help you out here. I'm looking for which one has more energy. So if I look at my two options, I would go with X-rays have more energy. What about between visible light or UV or ultraviolet? So visible light, remember, is this little section right here, or ultraviolet is right over here. Which one has more energy? That's going to be ultraviolet. Try to be guessing these in your head before I give you the answers. That way, it'll help you remember it and learn it better. Between my light, I have green light and I have red light. Which one would have more energy? Green light would. I can also ask you the opposite of this. So which one has less energy? Between orange and blue, which one would have less energy? This is going to be my orange. Which one would have less energy? Gamma rays, which are over here on my spectrum, or radio waves? Less energy would be radio. Remember, energy and frequency means very similar things. So which one would have a higher frequency? Infrared, which is right here, or UV? Higher frequency would be UV. Between green and blue, the blue would have a higher frequency. Between gamma rays and X-rays, the gamma rays would have a higher frequency. And again, I could ask you the opposite of this. Which one would have the lower frequency? Between green and yellow, the lower frequency, think about it, would be yellow. Microwaves or visible light. Microwaves are right here. Visible light is right here. Which one has the lower frequency? That's going to be the microwaves. And I can also ask you questions about wavelength. So which one has a larger wavelength? Which one has a shorter wavelength? So larger wavelength, X-rays or radio waves? X-rays are right here, radio waves are right here. Larger wavelength, that would be radio waves, right? My wavelength is larger on this end than it is over here. Between orange and violet, orange is right here, violet is right there. Which one has the larger wavelength? that's going to be towards this end, so my orange. UV, visible, which would have the larger wavelength, that would be visible. And the opposite of this, shorter wavelength, which would mean higher frequency, right? Gamma rays or microwaves, that would be gamma. And yellow and orange. Shorter wavelength, that would be my yellow. And that's all the information we need to know about notes. Remember, go through these videos again. If you need help, email me with any questions.